So we're going to talk about a quadrilateral called a kite. And some of the basic definitions we want to take a look at here are three different traits. So the first one is this particular quadrilateral has exactly two pairs of consecutive congruent sides. So the word consecutive essentially means they're going to be next to. And because it's exactly two pairs, that means I'm meaning two different pairs. If all of the pairs were the same, let's say, we would actually be looking at a rhombus. So as an example here, and I'll use the yellow highlighter, that would mean that this side and this side on the right side are congruent to each other, and then these two sides, since they're next to each other, they would be congruent as well. Notice that this side on the left and this side on the right would not be the same. The second property is that they have exactly one pair of opposite congruent angles. Now technically where that is going to occur at the intersection of the non-congruent sides. The reason that actually happens is that this line, or this diagonal we'll call it, is actually cutting this, if you look at it, I'll lay my highlighter down, into two isosceles triangles. The one on the left, the one on the right. Well, we know that the angle here and the angle here are going to be the same, and the angle on the right and the angle on this right are the same. Well, that means these two added together and these two added together are going to give you the same angle. So, this angle at the bottom, this angle at the top. Again, it's the ones connecting the non-congruent sides. Those were going to be congruent to one another. The last property is that the diagonals are going to be perpendicular to each other. And so what that means is when I draw the diagonals from opposite vertices to each other, so I'm going to draw my first one across here. May not be perfect, but there's my first one. That second one, which actually creates those isosceles triangles that I talked about, they're going to meet at exactly a right angle. This is important because when we do some problems in a few moments, we're actually going to be able to use Pythagorean theorem or even possibly SOHCAHTOA or trigonometry to help us solve for missing parts and missing sides. Here's our first example question. So we want to find the measures of the missing angles. So that would be this angle here and the one up top as well. So because we talked about opposite angles being congruent and exactly one pair, this 105, since it connects the non-congruent sides, is going to be congruent to this angle, which is also connecting the non-congruent sides. Right away, that makes this 105 degrees. Now, to figure out the fourth angle, we need to remember that the sum always is going to equal 360 in a quadrilateral. So I'm simply going to just go ahead, and I'll just do this on my calculator real quick. We're going to take 360, you may not be able to see that, 360 minus 105, minus another 105, and then we're going to minus a 50 from it. So that's going to leave me with 100 degrees left over, which means this has to be 100 as well. Try the next question, which is going to be this one right here on your own. Press pause and then play once you have tried it yourself. Okay, so here are our solutions to that question. So once again, the 88 is the angle that is connecting the non-congruent sides of my kite. So right away, angle E, since it's also connecting the non-congruent sides, is going to be 88 degrees as well. Just like the previous question, this 77 is derived because 88 plus 107 doesn't exactly equal 360, but the 77 being added to that sum is going to reach 360 for that. The last type of question this video is going to address is something like this. So we want to find the side lengths of the kite. Side lengths of the kite. So one of the other properties mentioned in the beginning of this video is that diagonals are perpendicular to each other. And so that means all four of these angles, I'm only marking one, are all going to be 90 degrees. That means I can create right triangles here and use things like Pythagorean theorem. For example, to find QR, Q, middle point, we don't have a name for that, R, this triangle in the upper right corner, I can do 4 squared plus 8 squared equals, and we'll call it x squared for our missing side. So that's going to give me 16 plus 64 equals x squared, and 16 plus 64 gives me 80. So when I take the square root of that, the square root of 80, well, is the square root of 80. They want the answer in simple radical form, so we're not going to get a decimal for now. So to actually break this down, we're going to make this, let's go with 8 and 10. Why not? 8 is 4 times 2, 4 is 2 times 2, I'll move my hand away, and 10 is 5 times 2. I'm going through this quick. Feel free to pause at any point if you need to go back to revisit it, but I have a pair of 2's, another pair of 2's, and so QR here is actually going to be 4 root 5 as our missing length. Now, since that's QR, because we know if a kite has two consecutive congruent sides, that means RS is actually also going to be 4 root 5 as well. We're going to do the same thing over here. So when I do Pythagorean theorem, and we're going to end up with, I'll call it x squared again, but we're going to end up with 32 equals x squared, which means the answer is the square root of 32. When I break this down, though, I'm going to end up with 16 times 2, and 16 is 4 times 4. This ends up being 4 root 2. So my other two sides, PS, whoops, I got to make that a P, PS and PQ, both of those answers are going to be 4 root 2. Now, as you look at those answers, you may notice this was a 45, 45, 90 triangle, but we were able to use Pythagorean theorem either way. So there are my missing sides. As the last question for you to do in this video lesson, I would like you to also take this kite in the last question and find their side lengths. Again, press pause and complete the problem. When you're done, press play to see the results. Alright, here are my solutions. So once again, I just did two Pythagorean theorems. The first one for triangle, for side length IT, 2 squared plus 6 squared equals x squared. I did my simplification. I get the square root of 40. Because we wanted our answer in simple radical form, I broke it down. Here's my work for that. And we ended up with 2 root 10. Now again, ET and IT are going to be the same lengths, so I didn't have to do the work a second time. So I got my first two lengths of the kite. Over here on the left side, I did 4 squared plus 2 squared equals x squared. Once again, another Pythagorean theorem. I get the square root of 20, breaking it down as we normally do, and we end up with 2 square root of 5 as my final solution here for that. This concludes the video on kites. Feel free to pause and go back and rewatch any of the examples or the definitions we talked about.